Bar chart heat maps and correlation matrices in Python, beginner workshop. Let us start exploring how to use Python and Seaborn to build heat maps and visualize relationships in data. By the end, you will be able to load a real dataset, draw a basic heat map, understand correlation matrices, solve a fun data mystery. Running the cell now. Are you ready to dive in? Let us get started. First, we bring in a few important tools for working with data and making charts. These lines make sure any warning messages do not pop up. Pandas helps us work with tables of data, like spreadsheets. Seaborn makes beautiful charts easily. Matplotlib lets us display or save those charts. Running the cell now. If you ever see errors about missing packages, use pip install to add them. Step 1. Loading a real dataset. We will use the airline passengers dataset. It tracks the number of airline travelers each month. Let us load it and peek at the numbers. Running the cell now. When you use real data, visualizations become much more meaningful. Let's see how this works. Let us load the data directly from the web. No downloads required. First, we tell Python where to find the dataset online. We load the CSV into a Pandas data frame, which works like a table. Now, let us see how many rows and columns we have. This prints out how big the dataset is and shows the first few entries. Running the cell now. Practice, try loading another CSV with Pandas later and using .head. Before making any heat map, let us make a simple line plot to see what the data looks like. We build a chart that shows passengers over time. Making the figure bigger helps us see details. The month column is on the bottom, and passenger numbers are up the side. Dots mark each month for clarity. The title helps us understand what the plot is showing. We add labels so the meaning of each side is clear. Rotate the month names so they do not overlap. This keeps the chart neat. Now let us see the plot. Running the cell now. Line plots help you spot important patterns before digging deeper. Step 2. What is a heat map? A heat map is a grid where colors show the differences in numbers or relationships. Darker or lighter colors mean bigger or smaller values. They are used to spot patterns, trends, or high and low spots in data. Let us make one. Running the cell now. Heat maps are great when looking at groups of numbers or comparing many things at once. Let's build a tiny sample grid of numbers just for practice. We use NumPy to build a mini table of numbers. This table is 3 by 3, just a few numbers so you can see the idea. Each row is a list of numbers. Now, we draw a heat map using Seaborn. Anat equals true shows the numbers on each tile. We use a color palette called YLGNBU, which goes from yellow to blue. The title reminds us this is just an example. Running the cell now. Nothing beats seeing patterns with color. Step 3. The correlation matrix. A correlation matrix compares many columns to see how closely related they are. Each cell shows a number called correlation. A value of +1 means a perfect positive link. -1 means a perfect negative link. In the real world, this is how we discover which variables rise and fall together. Running the cell now. Let us see how this works in practice. Let us build a small table with pretend numbers, then find out how each column relates to the others. We set a random seed to keep numbers the same each run. We make a small data frame with columns A, B, and C, each full of random numbers. The values in C are a bit different, with a little math to change their range. Now, we create the correlation matrix for these 3 columns. This matrix compares each pair and shows their correlation. We round the values to 2 decimal places to make it easier to read. Running the cell now. Try changing the numbers and see how the matrix changes. Now let us turn the matrix into a colorful heat map, so patterns pop out. The heat map colors will help you spot strong or weak connections in one glance. And equals true puts the numbers right into the tiles. The center color is for 0, meaning no link. We include a clear title. Running the cell now. Notice which squares are darkest or brightest. That shows where columns are most and least connected. Step 4. Heat maps for real data. Let us use our airline passenger data now. First, we will add a new column. Which year is it? Then we will see the average number of passengers for each year and month. Running the cell now. Real data is more fun. Can you guess which month will be busiest? Let us split the date into year and month so we can look for seasonal patterns. Here, we create a new column called year by taking the first 4 characters from each date. We also make month num by picking the month part from every date. Now we build a pivot table. Each row is a year, each column is a month. Each cell shows the average number of passengers for that month and year. Let us peek at this new table. Running the cell now. Monthly and yearly views help find trends you might miss otherwise. Let us see which months and years stand out with a colorful heat map. We make a bigger chart for easier reading. The heat map turns the table into colors, with numbers inside each square. FMT equals a 0.0 F means we show only whole numbers. The colors move from yellow to red for low to high. Titles and labels make everything clear. Running the cell now. Do you see any patterns? Which months grow the most over time? Step 5. Correlation matrix for the whole dataset. Now, let us check how columns in the whole dataset relate. This will be simple since the dataset is small, but it is a good habit. Running the cell now. Even small datasets can surprise you if you look for hidden connections. Let us see if there are any strong relationships hiding in our columns. Using .core compares every numeric column. We show the matrix, rounding for clarity. Look for values close to +1 or -1. That signals a strong connection. Running the cell now. Try adding your own columns and see how the matrix changes. Let's make this easier to see with a heat map. Color shows where columns are closely related or not. We use the VLAG color palette so positive and negative stand out. The numbers show exact correlations. The title finishes our chart. Running the cell now. Biggest squares mean the data moves together the most. Smallest means they move opposite, or not at all. Step 6. Mini project, heat map data detective. Suppose you work for an airline and want to spot your quietest and busiest times fast. Use a heat map to find the month with the highest average passengers, the month with the lowest. Let us find clues together. Running the cell now. This kind of detective work is how companies plan sales, flights, or even set prices. Let us group the data by month and get the average number of passengers. Group B lets us bundle all the same months together. We take the average for each month across all years. Print the results for a side-by-side comparison. Sorting lets us quickly see which months are highest and lowest. Running the cell now. Practice, which month would you suggest for a holiday if you want fewer crowds? Let us turn month averages into a bar-like heat map for another easy view. This chart is like a row of colored tiles, one per month. A bright spot means lots of passengers that month. Empty y-axis keeps the focus on months. The months are shown left to right. A short and wide plot is like a bar chart but with colors. The label reminds us which numbers are shown. Now see which months shine brightest. Running the cell now. Visualization can make even a row of numbers come to life. Step 7. Troubleshooting common heat map issues. If you see errors or blank charts, check for missing data, NaN. Make sure your numbers are not all the same. Look at color and labels. The more you practice, the clearer these will be. Running the cell now. If stuck, try printing out your data or using .info to spot problems. Let us quickly check if our passenger data is missing anything. Every real-world table should be checked for missing values. Printing this will tell us if any column has a gap. True means yes, there are missing values. False means you are all set. Running the cell now. Caught something? Try .filter or drop those rows to clean up. Recap: key ideas about heat maps. Heat maps are a simple but powerful way to see patterns in data. Try to add more columns to your tables. Practice grouping and reshaping with Pandas. Use colors to catch your eye on the big picture. The more you experiment, the more insights you will discover. Running the cell now. Practice tip: try making a heat map from other numbers you are interested in. Clapperboard, thanks for learning. Your turn now. Try these. Build your own heat map with other datasets. Change the color palette styles. Share your best charts in the comments below. Subscribe for more beginner Python and data tips. Running the cell now. Do not forget to give a thumbs up and subscribe to catch more lessons.